So now we're going to be looking at how two variables interact with each other and how they play on each other. So there's two different variables we're looking at, the dependent variable and the independent variable. So the independent variable, when you're making a scatter plot, will go on the x-axis. And this is the variable that you think will influence the other variable. The dependent variable is the one that you think will be influenced, the variable that depends on the independent variable. So we'll do some examples of the independent and dependent variable. So let's say we're doing a study that looks at the relationship between height and basketball ability. So which one would be the independent variable? So you think which one causes the other one, or which one would influence the other one? Well, your basketball ability is not going to influence how tall you are. So obviously the independent variable is height and the dependent variable is basketball ability. So now we're going to go look at scatter plots. So a scatter plot is a graph that you use when you have two variables, and it tells you the general trend of data. So when you make a scatter plot, you always make sure the independent variable is on the x-axis and the dependent variable is on the y. And I've drawn two different scatter plots that show different trends in data. So when the points are clustered, and this line shows the general trend, when the points are clustered in a way that shows this sloping upward line, it means that there's a positive correlation between the two variables, which means that as the independent variable increases, so does the dependent variable. Now this scatter plot shows a downward trend to the data, which means as the independent variable increases, the dependent variable decreases. So it's a reverse correlation or a negative correlation. So let's look at the different ways to measure a correlation. The correlational coefficient is one of the most used measurements, and it's got this huge formula that you can use to calculate it by hand, but most of the time we just use software like Microsoft Excel or a graphing calculator. So the correlational coefficient is labeled by the letter r, a lowercase r, and it ranges from -1, which means a perfect negative correlation. So that means as one variable goes up, the other goes down. A perfect negative correlation is -1. And it goes all the way to the other end of the scale, which is +1, a perfect positive correlation. So as one variable goes up, the other variable goes up to the same degree. Now 0, a correlational coefficient of 0 means no correlation. So a scatter plot of that would just show all the points scattered around with no discernible pattern. And then along both lines, you have different types of correlations you can have. You could have a weak negative or a weak positive, a moderate negative or a moderate positive, and then a strong positive or a strong negative. So a weak correlation means that it follows the trend, but the points aren't going to be that clustered together. So it would be a very loose positive shape for a weak positive. And that's the correlational coefficient between 0 and 0.33. A moderate is between 0.33 and 0.67, and a strong is anything above 0.67. So if you were to use the formula to try and calculate it, and you ever got an answer that's bigger than 1 or less than -1, you know you've made a mistake, because the maximum and the minimum values for a correlational coefficient are -1 and +1. The linear regression is another fancier term for the line of best fit. So the way we'll calculate that in this course using graphing software or Microsoft Excel. Now what that does is it puts a line through a scatter plot that shows the general trend of the data. So the closer the points are to the line, the better fit the line is. So there's two different things you can do using the linear regression line. There's interpolation or extrapolation. So interpolation is where you find data between the existing points. So if we were to look at this example, it would be somewhere between these 2 points that exist on the line, but we want to find a data point that's not recorded. We use the line and follow it. Extrapolation is where you find points that are not included in the original graph. So you extrapolate your findings and extend the line of best fit to find ranges that are far out.